Hi, I'm Malasop. Welcome to my channel. This channel does not use AI for voiceovers. Trust me, if I were using AI, you wouldn't be hearing me cough or sneeze or stutter or make jokes or laugh. This is my real voice, like it or not. Also, this is real cracking. I'm removing the copy protection from the games. I'm explaining it to you so you can learn yourself. Just because I'm using an emulator, which makes it easier than on an actual 64, doesn't make it less of a skill. It is still bypassing the protection. That is absolutely cracking. You might want to take a look at some of the releases being put out by cracking groups, which are actually free games with no protection, and they're just adding documentation or an infinite life and calling that a genuine crack. And try to be a little bit more positive. Now, we're going to get into a little bit of a tutorial here. In 6502, there are three registers, A, X, and Y. And you can think of those as three envelopes marked A, X, and Y. And those envelopes can be put into memory locations on the 64. So, as an example, I can load A with 1. I can load X with 2. I can load Y with 3. And I can put the A envelope into 0400. I can put the X envelope into 0401. And I can put the Y into 0402. Call it. I have to turn off the, there we go, ABC at the top left of the corner. Because A is 1, B is 2, C is 3. Next, we're going to move on to immediate addressing. So immediate addressing is where you have the number sign in a load command. This was something that I struggled with when I was learning machine language. I didn't understand what the difference was between load $01 and load number string 01. It was very difficult. You can read a book over and over, but unless you have someone beside you to explain it to you, it can be very difficult. So here's how to explain it to you. You're always going to use a $, always. That indicates it's a hex address. And if you want the actual value, the actual number, you're going to put a number sign. So if we put load and you want to have the value of 21, you're going to put number sign because you want the true number, and then $, 15 because it's hex. 16 plus 5 is 21. And then you're going to store at 0400. Another mistake I tried to do was put store number sign string 0400. That doesn't work. So just to go over it again, three registers, A, X, Y. If you're loading them, if you're putting something in that envelope and you want the actual number, you use the number sign and always put $. So 2A would be a star. We're going to store the envelope at 0400, SYS 828, and there's our star. So what happens if you don't use the $? Don't use the number sign, I mean. This is the other type of load you can do. You can load 03 and store in 0400 and do an RTS. And if we SYS 828, we see a reversed star. Why don't we have C, the letter C on the top left? Because we're taking what's actually in location 3. Is that a little muddy or is that clear? load 03, load X 03. The first one is going to put the actual number 3 into A. The second one is going to load whatever's in location 3 into X. So just remember that. Rule 1, always use a $sign. Rule 2, use number sign only if you want that actual number. Otherwise, it gets what's in the location. Oh, what else can we do? We can do kernel calls. So GSR FFE4. You've seen that before when we're looking for cheats. So GSR FFE4 is a kernel routine, and its purpose is to get a character. Its default is the keyboard. And if we put branch equal back up to 033C, the way it works is if it's called and no key is pressed, the accumulator, the A, has nothing in it. And a branch equal without a compare will go up on a 0. Just think of it like an invisible compare number string 00. That was something that confused me too. I was thinking, like, if there's no compare, how does it know it's branch equal? It branches because it's a 0 and goes right back up. So you can do a load 3, for example, and just go branch equal, and it will branch if it's a 0. If you put branch not equal, think of it as branch not equal to 0. And if you put a compare, let's just demonstrate. GSR FFE4, branch equal 33F. SY's 828, press any key, and it crashed. There's a good lesson. Oh, that's why. Branch equal 033C. If we introduce a compare command, compare number string 20, putting number because I want the actual number of 32, which is decimal. Branch not equal 033C, return, call the kernel routine, check what's returned in A. We want the actual number 20 in hex, not equal to 20, go right back. That's why it's 828. Bunch of keys don't work, space works. Do you really think AI could make this many mistakes? Come on. What else? FCE2. In my last video, I spoke about the NMI registers. The NMI is at 0318 and 0319. You'll see that it points to FE47. We always put the low byte first. So the high byte is multiplied by 256 and the low byte by 47. Well, you just add the low byte. If we set it to E2FC, which is system reset, and I press restore, it resets. So you can put that in your own games if you want to have some sort of protection. You can point this to a reset. You can make it restart the game. Just something for your knowledge. Why do I put programs up at down at 033C? It's a safe spot. 033C is, so we take 3 times 16 plus 12, which is C, 12, and we get 60. 3 times, because 3 is the high byte, 256. So 768 plus 60 is 828, the cassette buffer. Safe space for code. And with that being said, we're going to get into today's video, which is the great Giana sisters. I think I've pronounced it correctly. The great Giana sisters. We're going to look not only at cracking it, but trying to find infinite lives and make it a trainer. In the second half of this video, we're going to take a look at the great Giana sisters and the copy protection involved. An examination of the disk shows a 1-block loader file, a 250-block file named 1, an 80-block file named 2, and 2 smaller files. If I had to guess, I would say F is possibly the fast loader, 1 is most definitely the game, and 2 is probably a loading picture. We're going to load the first file on disk, and we see there's a disk error. I'm thinking that's probably a high score file that's missing. We have an intro, press fire, and the title page comes up. There is music. I have to say this kind of looks more like a dude than a female, but it is 2026 after all. We're going to do a freeze by pressing F12 in CCS. In Vice, it would be, I believe it's Alt F11 and Alt F10 to restore the freeze. I'm going to press fire and pay attention to the track. It goes up to track 36, and now it's trying to write to a whole series of tracks. If I had to guess, I would say it's trying to self-destruct the disk. Fortunately, I have disabled writing to the disk, so this is a somewhat nasty protection if it is trying to scrub the files. We're going to go into the monitor with Alt-M. In Vice, that would be Alt-H. The program counter is B61. So we're going to disassemble around B61 to see what it's doing. The program counter tells you what is currently being executed. Load DC01, and it with 16, 10 decimal. I'm sorry, and it with 10 hex, 16 decimal. Branch not equal B5E. So this is a loop. If we check here, joysticks as seen from the C64. Bit 4, weight 16, goes low if the fire button is pressed. Low means it becomes a 0. The bit becomes a 0. So it's loading the joystick port, turning off all the bits except for 16. If it's not equal, which means that it's high, it's a 1. Fire is not pressed. Loop. This loads D012, which is the raster line, and waits for it to hit FA, which is about here. If not, go right back up. It restores 0314, 0315, which is the IRQ, and 038, 0318, 0319, which is the NMI. And then it does a jump to 334, which is the cassette buffer. Let's put a breakpoint in at 334, where it's executed. FFBD is the file name. A is the length of the file name. It's 1 character. Y is high, so it's 0359. 0359 is the name of the file it's going to load, which is 1. It calls FFD5, which does a load. BCS means branch carry set. That means an error has occurred on the disk trying to load the file. If the carry flag is set, something happened. It didn't load properly. And it gracefully just crashes if that's the case. Otherwise, it jumps to 820. Let's load 1. That's done. And remember, it executes 820. Just for fun, we're going to look at 2D and 2E to see where it ends. And this file ends up at FFF1, so this is huge. Bank 0 to turn off the kernel and basic ROM so we can see under it. And I'm just going to scroll through the memory using the I command. So I 0800, which is the start of basic. You can see here it was SYS 2062. I'm just quickly scrolling through. I'm not looking for anything. I'm just scrolling through. Slowing down at A1000 to see what's there because this is normally the basic interpreter. C1000 is in use. Right up to FFFF, so this is using all of memory. We know that 820 is the start address after it loads the file. So it JSRs C800, and then it does a jump to 832. C800 calls C873. C800 calls C873. And here we can see it calls C902. We'll go back up here. It loads AE, comma Y. This is indirect addressing, so it's using whatever's in AE and AF as a pointer and calling FFA8. If something is calling FFA8, you can be pretty certain it's a disk drive command. Load A with 43. Store A in AE. AE is going to be 43. AF is going to be C9. Load C862, comma X, JSR FFA8. C862. See how it's load X with 6 and decrementing X? This doesn't really make a lot of sense unless you know your drive code. And then you can read it backwards because it's loading X with 6 and decrementing X. It's starting at 0, 1, 2, 3, 4, 5, 6 and decrementing X, so it's reading it backwards. Memory write. It's calling a memory write command to the drive. And then it's loading AE, which we know is C943. That is totally incorrect. C943. I'm thinking right here, this is track 36, that it's storing an 8. So it's going up to check the signature file. What I'm primarily concerned with is this does a JSR, and then it's checking branch carry clear. If so, just return. Now, if you're not familiar with protection, this might not stand out, but what a lot of programs do is they set a flag. So SEC sets the carry, and CLC clears the carry. Think of your math when you're adding 34 plus 29. Your carry would be up here, it would become a 1, and it would become 63. So that's what the carry flag does. It says, okay, we have to carry the value. So I'm just going to break it down. We know from looking at the loader that this huge file calls C800. We know that C873 is doing some memory writes, memory executing to the drive, and it's checking if the branch carry is clear. If so, it does an RTS. So we don't know if this is good or if it's bad. Maybe it's supposed to do an RTS. If not, it goes to C8, C3. Where it loads Y with 4, C869, comma Y, 0, 1, 2, 3, 4. So it does a memory execute. I'm thinking this could be where it tries to do some nasty things to the drive. But the real teller will be right here. Load C81C, comma X, where X is 0. Store in 0, 100. Increment X, BPL C8OF. So what it is doing is it's setting X to 0, loading C81C plus X, storing it in 0100, incrementing X until it wraps around, and then jumping. So it's copying this into 0100 and then executing it, which is this code right here. We see it loads X with 0, transfers X into A, and fills 2, 3, 4, 500. Fills FE and FF. Oh, and then it does an FFFC. So I'm thinking this is not what you want to have happen. This is almost guaranteed to be clearing out memory and crashing. Otherwise, it does an RTS. So we have a couple of options here. We can try to dismantle the drive code. We can take out all of this. But the easiest course of action is just to follow it through, just for the sake of going over it a third time. It's JSRing to C800, so we know that as it's a JSR, it's going to come back after an RTS. This is like a go sub. Go up to C800, come back when you hit RTS. We know that this is doing memory write, memory execute, checking if the carry flag is set, trashing memory, and resetting. Otherwise, go do an RTS. The answer is right on the cursor. RTS. Ignore all of this and just go right back when you're done. In other words, all we have to do is change 1 byte. Get rid of this JSR C800. And we can do that by changing the 20, which is the opcode for JSR, change it to an AD, so it becomes a load. It's going to load A with C800 instead of executing C800. And then it is going to read 1639, which is ATG, probably all-time great, like a high score. I'm going to save the freeze. I'm going to see what 820 is in decimal, 2080, and we're going to SYS 2080. And there's the game. So this signature up on track 36 was just a matter of one single byte to crack it. In this part of the video, we're going to take a look at training a game. Training originated a little bit after, a few years after the 64 was released, when crackers wanted to fully test their games and make sure they were working. So what they would do is they would put trainers on their games without menus, just altering the code to make sure that they didn't lose a life when they died. That way they could play a game right through to the end and make sure the crack was good. Eventually, someone decided that they would add it as a feature for players. And then came infinite lives, infinite energy, infinite bullets, and then mega trainers where you could change weapons inside of a game. And it just kind of progressed from there. And then there were high score savers added to games that didn't have high scores saved to disk. So what we're going to do now is we're going to attempt to train the great Giana sisters. And we're going to, first of all, disable the protection. And then we're going to run the game and start it. Right away you see I have 0 score, 0 bonus, 3 lives, stage 1, and 99 for time. So there are different means that you can use to try and find the lives. One I like to use is checking 0 page, which is from 0 to 0100. I guess technically to OFF, and see if there's a 3. So we have one at 53, 9A, B7. 53, 9A, B7. And I'm going to die. I'm going to check 0 page again, and we don't have the same locations. So that didn't work. I'm now going to check to see if it loads the accumulator with 3, because we have 3 lives, right? So A903 is LDA number string 03. The game could use LDX, it could use LDY, but I find about 95% of the time, if you have 3 lives, it's going to be A903. So we're going to take these results that we found, indicating that it does have a load 3, and just see what it's doing. This is a disk command that's loading the high scores. This one is going to 41C9 with it, and that's jumping to 49E6. Nah. 98E. This is looking good. Load the accumulator with 3, store 1573, store 1574. 2 consecutive locations, and it is a 2-player game. Let's try losing a life and see what happens. Well, we've already lost a life, so let's just check. 1573, 2 lives for player 1, 3 lives for player 2 who's not in the game. Let's give it another try, and we're down to 1 life. So we have found the infinite, not the infinite lives, but we found the lives portion. The next step is to go into the monitor and try to find out where it's decrementing that location.
So what I like to do is just do a search for CE and then the location with the lives. CE is the opcode for decrement, so it would be decrement 1573. It didn't find anything. So we can set a breakpoint for 1573 where it writes to it, and the format for that is BA, breakpoint add under CCS 1573 W for write. You want to know when it's writing to the location. On Vice Simulator, you would type breakpoint 1573 store. I think it's in that order. It could be store and then 1573. And the breakpoint kicked in at 0A09. We can see here that it's taking 43C and storing it at 1573, Y. So I would assume that Y is 0, and then if it was player 2, Y would be set to 1. I'm just going to retrace what we've done in case you're getting a little confused. We know we have 3 lives, so we search for A903, which is load number string 03. And then we have to manually go through them all. Fortunately, we found one not too far in here. We checked the value of the locations, lost a life, and noticed it did decrement. Then we set a breakpoint for it, and we found that it decrements at around, well, it doesn't decrement, it actually loads 43C. So what we're going to do now is we're going to do hunt for CE3C04, and that is decrement 43C. CE is decrement, and then of course we have the high byte, low byte. 2041 is our loss of life because it decrements 43C, and then it takes it and it puts it in your lives remaining. Change that to an AD. Location 2041 becomes AD, so it just does a load, and then it does a load right after, so this is effectively meaningless. Speed it up to 500%. Let's get rid of the breakpoint. 2 lives, 2 lives, and we have successfully trained it.